So we're going to talk here about preparing a pure dry sample of an insoluble salt from two soluble salts. An example might be barium chloride as one of the soluble salts as a starting point. Barium chloride. And another soluble salt that might react with might be sodium sulfate. Now if you go back to the solubility table above, we can see that both those are indeed soluble because it says here common chlorides are soluble except those of silver and lead. Now barium chloride is not silver or lead, barium is not silver or lead, so it is a common chloride and it's soluble. Likewise, sodium sulfate, if we come up here, it tells us common sulfates are soluble except those of lead, barium and calcium. Well, sodium is not lead, barium or calcium, so it is soluble. Now, when you mix those two together, they react. And the way the reaction works is the anions and the cations in both salts swap over. For example, the cation here in the sodium sulfate is a sodium, and it swaps with the anion in the barium chloride. That sodium takes that chloride. And likewise, the barium here is the cation in this salt, and that takes the anion from the sodium sulfate. So that there's one just great big swap shop going on, where the cations and the anions swap over. So this makes barium sulfate, sulfate, and sodium chloride. Now, if we look at the solubility rules from above again, barium sulfate now. Well, back to the common sulfates. All common sulfates dissolve in water. All common sulfates dissolve in water. But over here now, there's a couple of exceptions, except those of lead, barium and calcium. Barium sulfate, so barium sulfate doesn't dissolve in water. So this one here is a solid, so let's put a state symbol of a solid next to that, and these were before AQ, they dissolve in water, and that's aqueous. Sodium chloride, well, I think we all know that sodium chloride is common salt, so seawater, so we know that dissolves in water, but let's check the table anyway. Common chlorides are soluble, except those of silver and lead. Well, sodium is not silver or lead, so common chlorides are soluble, they dissolve in water, so we can put an AQ next to that. So what this basically means, if you mix these two together, which are basically two soluble salts, so colourless solutions, quite possibly, then what you will get is a precipitate. A precipitate is a solid that forms from when the solutions mix, so it's a solid. So you get a precipitate falling. Now, what we want to do is get a pure dry sample of that. Okay. Now to do that, we just need to remember three words: filter, wash, dry. And these in these boxes up here, we can just draw the apparatus that you might need for that. Now I would recommend you draw these with a pencil and ruler and spend a lot of time on them, because you just have to remember that you mix the two together. So for example, what we have here is we have a test tube, I suppose, of one and a test tube of another. What we're going to do, we're going to put those both into the beaker there, and we mix them together. That'll be the barium chloride and the sodium sulfate mixing. And what we're going to end up with is a cloudy precipitate. What we end up with there is a precipitate forming. That precipitate forming would be the barium sulfate. So after we've done that, we then need to filter, wash and dry it. So what we've got to remember, we have to remember filter, wash and dry. Okay, which is why sometimes it's quite good to draw out the apparatus, because it helps us remember it a bit better. Okay, so what we're going to do is take that solution that has been formed, and it's going to go straight in the top of that filter funnel. So the precipitate is going to end up in the filter paper. Okay, the sodium chloride will end up down here. We don't want the sodium chloride because we want a pure dry sample of the insoluble salt, the barium sulfate. That's what we want, and it's going to end up there. Now, because it's insoluble, okay, it's not going to dissolve if we put any more water out. So after we've filtered it, we're going to have the filter funnel still there. We're not going to touch it at all. We're just going to put a filter paper in there still. The filter paper is still in there, and there's the precipitate. The barium sulfate precipitate is still in the top there, just there. Still a beaker beneath it now, but that barium sulfate is going to be wet, and it's going to be wet with sodium chloride, and it's going to be wet with whichever of these reagents on the left was in excess, because there will have been too much of one of them. You won't have exactly the right amount of both to react. There'll be too much one. So it's not going to be pure. It's going to be wet with the impurities of an unreacted reactant and with the sodium chloride product. So what we need to do afterwards is we need to get a squeezy bottle of distilled water, and it's important it's distilled water so there's no other ions in there, and we need to squirt the distilled water onto the top of it. So we're going to wash it with water. So that's going to be distilled water. And after we've done that, we're going to take the filter paper out the top, because that will now be clean. It will now just be wet barium sulfate with absolutely pure water, so we just need to get the water off it. So we're going to open the filter paper up at the end, and that precipitate, that barium sulfate precipitate, will be in the middle there, and we just simply need to leave it to dry. So filter, wash, dry. And that's the key things that we remember there for an exam question. Filter, wash, dry.